Question 31. A bag contains 8 red balls and some white balls. If the probability of drawing a white ball is half of the probability of drawing a red ball, then find the probability of drawing a red ball and a white ball if the balls are drawn without replacement. Now let's take the number of white balls to be n, and the question already tells us that the number of red balls is 8. And so the probability of drawing a white ball will simply be the number of white balls, which is n, all over the total of balls, which is n plus 8. And the reverse will be the same for probability of drawing a red ball, which will be 8 all over n plus 8. And so the probability of drawing a white ball, like the question says, is half the probability of drawing a red ball. So we simply take this, which is probability of a white ball, and replace it here. The same for the red ball, replace it here. And so that means that with 2 cancelling 8, this will be 4. The denominators are the same, so they cancel out, and n is equals to 4. So the number of white balls is actually 4. So now we know that the number of white balls will be 4. That means that the total number of possible outcomes is 12. The question asked us to find the probability of drawing a red ball and a white ball if the balls are drawn without replacement. What this means is that after drawing any ball, right, normally I'm meant to put it back into the box, but this time no, there's no replacement. So for example, if we're starting with 12 balls, when I take out one ball, there are actually only 11 left. So let's assume that, or the probability of drawing both a red ball and a white ball is simply the probability of the red ball multiplied by the probability of a white ball. So let's assume I draw a red ball first, right? So there are 8 red balls. So the probability of drawing this red ball will be 8 all over 12. So since I've taken one ball out, that means there are 11 balls left. So that means that the probability of getting a white ball will be 4 over 11. And the order actually doesn't matter because the denominator is what we're really concerned about. If this was 4 over 12 and this, if you drew a white ball first, so that would be 4 over 12, and then you drew a red ball later, that would be 8 over 11. You will find out that the probability will still end up being the same, 8 over 33, because 4 will cancel out 12 here, 3. So that means that this will be 8 over 33, and our answer is option D. Now, question 32 says that the ages of students in a small primary school were recorded in the table below. So once again, we have a grouped, we have a grouped table. So we have ages 5 to 6, 7 to 8, and 9 to 10, and these are the various frequencies. And we're meant to find the median. So the first thing we do is that this is the table, So we have the total number, which is 29 plus 40 plus 38, the total frequency, which is 107. And the first thing we do is that to find where the median age occurs, we add 1 to this number since it is odd, So we add 1 to it and then we divide by 2, meaning that the median is actually the 54th value. So it actually occurs, around here. This 7 to 8 group is where the median of the ages occurs. So the formula for median is actually this, where IM represents the lower class boundary of the median age. And how do I find the lower class boundary? Now we know that the median age is somewhere around here. The lower class boundary is simply 6, the middle point between 6 and 7. So 6, which is the higher bound here, and 7, which is the lower bound here. Lower class boundary for this will simply be 6 plus 7, 13 all over 2, which is 6.5. Now the summation of the frequency, total frequency 107, like we got from here. FB, F subscript B here, stands for the sum of all frequencies before the median age. Now we know that the median age occurs in this 7 to 8 bracket. So the frequencies before that bracket are the frequency is just 29. So that is 29. And then FM is the frequency of the median age itself, which in this case is 40. And then the class width, it's simply the upper bound minus the lower bound. Calculated lower bound the other time to be 6.5 here, and then the upper bound will be 8.5. So when you do 8.5 minus 6.5, we find our class width to be 2. So now we have all our values. We simply put them into this formula. And so when you place them into the formula, you have this, and then you solve and you get your median to be 7.725, and that is option A. Question 33, we have the product of these two matrices, A multiplied by this matrix will give us this, and we're meant to look for the matrix A. Now, let's assume that this matrix A is A, B, C, D, since we don't know what it is. So that means that this can be rewritten as this. So this is the matrix we're looking for. When it's multiplied by this matrix, it gives you this. Now, we know that the way that matrix multiplication works, or the product of matrices work, is that We take this first one. So this first one, this A multiplies this 0. Then you add B multiplying this 2. So that now gives you this first number here. Then for this other number, it is simply A multiplied by this other number plus B multiplied by this other number, right? So that gives you this number here, as you can see, -1. The same applies to the bottom of the matrix, the bottom row. So this will be 6 multiplied by 0 plus D multiplied by 2 for this number, and then C multiplied by 1 and then D multiplied by -1 to get this other number. So we simply equate this to this, equate this to this, equate this to this, and then this to this to be able to get the four numbers of the matrix A. So when you solve for here, this is 0, so this becomes 2b automatically. This 8 times 1, so this becomes A. -1 times B will be -B. So the same thing for the bottom numbers, and so this is equals to this. And so we compare both sides like I said earlier, right? So that means that 2b will be equals to 2 here. Now if 2b is equals to 2, that simply means that b is equals to 1. Now a minus b is equals to -1, but we already have b from here, so we substitute b into here. So that means that a minus 1 will become -1, and if we take 1 here, that means that a is what? 0. Now we'll do the same thing for the denominators. 2d will be equals to 1, and that will make d to be half, and then c minus d will be equals to 0, but I have d already to be half. When I substitute d into this, it becomes c minus half 0. Half comes the other way, and then c is half. And so that means that my A, the matrix A, is actually 0, 1, half, half, which is option B. Question 34 says, how many students scored at least 25%? Now we can see the percentages obtained here, right? There's 0 to 25, 25 to 50, 50 to 75, then 75 to 100. The question is asking for at least 25%, meaning that we only want 25% and above. So that means we are not considering this frequency. So we start from this frequency here, right? Which we can see is 5. Then the 50 to 75 is 3, and then the 75 to 100 is 8. So when you add all this together, 5 plus 3 plus 5 plus 3, which is 8, then you add 8, then that becomes 16. So that is option A. Now question 35, sorry. It says that if this function is divided by this, then the remainder is what? Now, you actually do not have to divide this to be able to find what the remainder is. Thankfully, there's something known as the remainder theorem. So let's assume that this function is a function called px, right? So now, using the remainder theorem, what the remainder theorem is telling us is that we let the number that is dividing, or we let the function that is dividing, we equate it to 0. So in this case, x plus 1 will be 0, which means that x is equal to -1. And all I simply do is that I input -1 into this function, and whatever I get is actually the remainder when this divides this. That is the remainder theorem. So since x plus 1 divides px, that I said, the remainder will be p -1, right? So when you put this into this, you get this, and that number is actually -30, which is option C. The question 36 says, let a binary operation asterisk be defined on a set A. The operation will be commutative if. Now, the answer to this question is actually A. So, question 36, the answer is A. That means that A asterisk B will be equals to B asterisk A. What does it mean for an operation to be commutative? It means that no matter the order of the numbers involved, the operation will still give you the same thing. So, for example, addition is commutative because 2 plus 3 is equals to 3 plus 2. Multiplication is commutative. 2 times 3, which is 6, is also 3 times 2, which is 6. The order does not change anything. But now, division and subtraction, they are not commutative because 2 minus 3 is -1, but 3 minus 2 is 1. The same thing, 10 minus 2 is 5, but 2 over 10 is 1 over 5. So you see that division and subtraction are not commutative, but addition and multiplication are. So our answer is option A. Question 37 says we should solve the following quadratic inequality. Now this is the inequality we are being given. So the first thing we are going to do is that we'll take this 2 to this side so that this side will be 0. So it looks like a proper quadratic equation. So we take 2 here, it becomes -2. -4, -2 becomes -6, right? So only 0 is left here. So now we set it to be equals to 0. So we'll We temporarily forget this and we set it to be equal to 0. So something like this, and then we factor and solve like usual. So how do we factor? Now we multiply the coefficient of x squared by this number that has no variable attached to it. So 1 multiplied by -6 is what? -6. And then we find two numbers that when we multiply them, we get -6. When we add them, we get this -1, which is the coefficient of x. And those two numbers are actually 2 and 3. 2 and -3, sorry. 2 times -3 will actually give you -6. But then 2 minus 3 will give you -1. And so we replace this with this. So that will be plus 2x minus 3x, which is the same thing as this. And then the next thing we'll do is that we factorize. So when you factorize, we bring out x here, it becomes x into x plus 2. We bring out -3 here, it becomes -3 into x minus 2, right? Now this, sorry, this should be x plus 2. So yes, because when you bring out -3 from here, then it becomes plus because you've taken out the negative. So this should be plus 2. Please take note of that. And so you see that x plus 2 is common to both numbers. So that becomes x plus 2 into x minus 3. And that is equated to 0. So that means that x will be either -2 or 3. But now remember that this is an inequality, right? So the question now is, okay, how should I know whether the x I'm looking for is going to be between -2 or 3? Is it greater than, is it less than, or whatnot? So the first thing I would suggest you do is that you find, you take a number, any number between -2 and 3, and find out if it's, you know, if it is, if it fulfills the conditions that are given here. So for example, let's take 0, which is between -2 and 3. So that means that 0 squared, which is 0, minus 0, will be 0, -4. And -4 is actually less than, or equal to, it's actually less than 2, So that means that the x we are looking for is actually somewhere between -2 and 3. So we find out that any number that is actually from -2 to 3, fulfills this condition. If you try any number less than -2, you find out that it doesn't fulfill this condition. Try a number greater than 3, you find out that it doesn't sustain this condition. So the answer is B, right? Now question 38 says, what is the general term of the sequence 3, 8, 13, 18? Now, this sequence is what we call an arithmetic progression. And why is it? We can find out that this has a common difference, right? If I add 5 to 3, I get 8. I add 5 to 8, I get 13. Add 5 to 18 to 13, I get 18, so on and so forth. So the first term in this sequence is 3. So that means that our first term A is 3. And the common difference, like I mentioned earlier, is 5. And so the general term for an AP is given by Tn is equals to A plus n minus 1d. So if you want to find any term, so for example, if I had the term for the AP already, I simply have to put the term I'm looking for here. So let's say I was looking for the fifth term, so I'll put 5 here. I'll put the common difference on the first term, and I can actually get the term. We'll see that once we have done finding the term now. So now we'll put our 3 here, which is the first term, put our common difference here. You open the brackets, so the term is 3 plus 5n minus 5. 3 minus 5 is -2, so that means our term is, or the term of the sequence is 5n minus 2, which is option A. Now let's assume I want to find the third term. Now I'm just going to simply put 3 here. 3 times 5, 15 minus 2. You can see it's 13, right? But let's assume I want to find the fourth term. 4 times 5 is 20 minus 2, which is simply 18, and so on and so forth. Now, question 39 says that the locus of a point equidistant from two intersecting lines is, and the answer to this question is actually D, which is that a pair of bisectors of the angles between the two lines. So you can see this diagram